Installing a power cube on HVAC, also known as an air conditioning unit. Remember, safety first. It is up to you to know if it is safe. Protecting yourself will protect your client. Do not work on anything dangerous. Wear safety glasses and drink plenty of water. Turn off all electricity to the access panel when you are working on it. Pay attention and respect the client's property. If it is above 100 degrees, it is not advisable to walk on asphalt shingle roofs. It can cause damage to the roof. Assess the location. Look for any damage, rust, etc. to the outside of the control box or distribution panel. Upon opening it, look for apparent signs of damage, exposed wires or missing parts, evidence of rodents or other infestations such as yellow jackets, bees, or wasps. Note any damage and take a photo and tell the customer before you begin work. If it is dangerous to yourself or the client's property or person, do not proceed with the work. Please call a qualified electrician when necessary. Safety first. Thank you. Some basic safety tips. Electricity can maim or kill you. Be aware of what you could touch or are going to touch. Wear protective gear whenever possible. Those two metal things, even though they look like nothing's happening, they will certainly ruin your afternoon, your day. Those two metal pieces right there, they are not to be monkeyed with, touched, or fiddled with. These two. This is the main circuit breaker. When this is in the off position, these are not energized, but when it's on like it is right now, it's on and it will shock you and it won't stop till it's happy, so don't touch it. So again, be very careful inside the box. Do not touch any bare metal that is not painted. The painted metal is usually grounded. This metal up here that's bare and raw, that will shock the crizzle right out of you. Also, if it's copper, don't touch it. Anything that looks like aluminum or copper, stay away from. Do not touch. It will kill you. We're going to do an installation at the load on a split air conditioning system. So first thing we're going to do is access the main panel, which is right here, and we already got the screws loosened up. So pop those out. You need to set these over to the side, because what will happen is, if you don't, they'll get lost. Then with the flathead screwdriver, we're just going to gently pry up on the lip so that it comes out of the area that it's seated in. We're going to look inside the box right here, and this is the master on-off, which I've switched off right now. And this is full of live electricity, so don't just arbitrarily go starting and touching stuff. Those contacts will stay energized unless you turn off the main circuit breaker to the air conditioning unit at the circuit panel. So there's your safety on-off right here. This is your main on-off right here inside the unit. This is the contactor right here, and this is the power inside. And this is the power out to the compressor, which is down here. And if you look at the wires come from the compressor and they go up through this opening right here. So if we come back up here to the top, I'm going to bring the camera around over to this side right here. We're going to take some initial readings on this unit. At this time, we're going to ask the customer to turn on their air conditioning system, full blast, drop it down to like 66 degrees or whatever it is so that it runs continuously. One other item, do not put anything on that right there, because when you do, it's going to blow it away when you switch it on. So you don't ever want to place anything on the fan. So we've identified the two leads that we're going to use to measure. And the first thing we do is we take our trusty dusty meter here. We're going to clamp on this leg here. This one has a red line on it. It may be faint to see. This one obviously has no red line, so this is going to be leg 1, and it's black. So the next thing we're going to do is we're going to come down here. Let's see if I can show it. So if you're looking here, this is where the ground bar is down inside here, like so. So we're going to clip on our black lead onto the ground. So I couldn't get a good finger hold on the ground bar at the bottom, so if you notice right here, there was a ground wire out loose where I could clip onto it, and that's legal as long as you can ground it. And then the other thing we did up here is I clipped on to the actual nut off of the circuit breaker tie down. You see those screws right there? Well, they protrude out far enough so that I could clip on my alligator clip to leg number 1 so that I can measure the voltage through the clamp meter.
The only alternative to clipping on is to use the pointed probe on the red lead and hold it against the back side of the circuit breaker. This requires an extra set of hands or a really careful and coordinated technician.
So what we're going to do is we're going to switch it on, and we're going to wait about 1 minute so that the air conditioning can stabilize. And you have to wait for it to come on. Sometimes it takes about 5 minutes for it to cycle. So now that the air conditioner's been on for a while, we're going to start taking our measurements, and we're going to let it calibrate for about 15 seconds before I start. Actually, let it wait 30 seconds before it starts. When you shut the main power off, it may shut the power off to the thermostat, which is what happened to us. So I had to actually go back in the house, ask the customer to turn the air conditioner back on, or request to do it myself. Either way, you're going to have to, if it doesn't come on in 5 minutes, some of the dual packs and some of the other systems, when the energy has been turned, when the power's been turned off to the air conditioning units, it has a 5-minute reset. So if you're on the roof and you throw the power back on, you'll hear it go click, you'll hear the condenser fan start blowing. Sometimes it can take 5 minutes for it to recycle. Not recycle, but reset, for the cycle to complete the startup cycle. Okay, so now that it's running, let's start taking our readings. It's been about 30 seconds. So this is on leg 1, and it looks like it's developing 2.5 horsepower. And it's generating 1.90 kilowatts. And we'll go to the next range mode, which is power factor, and it's showing that it's 8.44 on the initial power factor, and it's lagging. It's at 1.22 kVAR. And it's lagging 32.3 degrees. And 2.27 kVA. It's at 121 volts and 18.75 amps. Now, for you guys that don't have a fancy schmancy meter like this, all we need is your volts and amps to do your actual install test or to do your sizing test, because we have a good ballpark idea of what it's going to take to correct the power factor and help save the customer some money. So now we're going to clip on to lead number 2. Be very careful, because this box is energized. You don't want to get electrocuted, even shocked very much. Now we're going to clip on to this lead right here. And We're going to let it calibrate for about 30 seconds. Okay, it's been a little over 30 seconds, but that's alright. So we'll go through and we'll check our readings. We have 2.62 horsepower. And we're showing 1.94 kilowatts. We have a power factor of 0.858. It's lagging. We also have a 1.18 kVAR. We'll actually have our true degrees coming up here. So we have 31.1 degrees lag, and we're 2.31 kVA. We're at 118.1 volts, running at 19.47 amps. Alright, so I'm going to go over and install the power cube, and we will come back and check the readings on installation. We need to find a suitable mounting location. Now this is going to be inside the unit, like so. And let me pull this over here so you can see what I'm talking about. So it's going to be inside the unit. So I can mount it right here on the side of the box, inside, and because it's inside the unit, it doesn't need any conduit, because as you notice, all these wires are loose. Everything in here is loose. But you have to make sure that you run the wires into the control section through the high voltage knockout. You cannot use the low voltage knockout. The low voltage knockout is over to the side, over here. Nothing goes through that knockout except for low voltage. You got to keep them separated. So we found a suitable mounting location over here on the side, right there. And there happens to be a happy little hole already made, so let me get a screw. These are self-tapping sheet metal screws. I'm going to set that right there like that. Get that going right there. And always look on the other side, make sure you're not going to drill into something you don't want to drill into. I'm going to make an initial mark right here. And the other thing is make sure your clutch on your drill is set so that it won't strip the threads after the unit has been installed. Alright, next up we're going to feed the wires through. So you're going to take your wires like so, thusly. You're going to push them up through one of the knockouts that has high voltage through it. This one right here is a perfect one. And make sure that the power is shut off to the box, because the last thing you want to do is touch something that's hot. So this particular box, even though this is shut off, if I hadn't shut it off over at the circuit breaker, these connections would still be hot. So you have to make sure you shut off the unit at the circuit breaker. This right here is the ground, where the ground gets strapped in. This is an aluminum ground, and that's an aluminum strap. So the only way that you can put this copper and this aluminum together in this strap is to use some what's known as Noah locks. So I'm going to strip off some of the insulation on there. I'm going to put on this connector, push it through a little bit, and then we're going to crimp it. Make sure it's on tight.
feed this through so we can put it under one of these screws so it can be grounded. By the way, you may want to wear gloves when working with the sheet metal because it's sharp. Sharp, sharp, sharp. Just use it as is. We're going to back it off a little bit. Slip the ground under like so, and tighten it back down. Once again, remember to keep all this stuff shut off because the last thing you want to do is get electrified. Alright, then we got these two leads here. We're going to cut, if it comes with a little bit exposed, get rid of it. And then I'm going to cut off some of the insulation. Use the appropriate size on your stripper, just don't use any opening. Make sure you're using a 12. Because that's going to be the one to use. It doesn't want to go on smoothly the first time. Cut it back and put it on again. If it doesn't want to go on at all, you may have the wrong size connector. Hold on a second. So, those are loose. So we'll put one under one. Remember to make sure the power is off. The last thing you want to do is get zapped for no good reason. Have to turn this one upside down to make it go in there correctly. So that one's in upside down. That way it'll nest nicely. Tighten it up. Make sure it's good and snug. Take the other one. Slide it under the other leg. Make sure it's loose so you can get it in there. Alright, now that it's attached properly, we'll tighten it down. Okay, now we'll tug on it a little bit, make sure it's good. Make sure this is tucked out of the way. Down here, as you notice, electricity is still off. So we can move all our tools. We're going to fire this hot dog up and see how it works. Alright, let's take a reading. 2 horsepower. And remember, we're on leg number 2 at 2.12 kilowatts. .989 lag, 0.994 lag. .29 kVAR. 0.211 kilowatts. We're at 8.3 degrees lag. .15 kVA. 119.4 volts. And 18.17 amps. Get back on that one right there. 30 seconds to calibrate. Alright, so it's been 30 seconds. So let's look at this one here. We got a horsepower of 3. Well, now it's 2.99. And 2.22 kilowatts. 0.994 lag, the power factor. 0.29 on the kVAR, and 0.224 on the kilowatts. Now we've got 5.6 degrees lag, and 2.26 kVAR. And we have 121.7 volts at 18.69 amps.
If your power cube is sized correctly, you will see a drop in amps. Since there has been a drop in amps, the power cube has successfully been installed. If the amps are not lower, try a smaller power cube, but at no time do not leave any power cube attached if amps have increased. It can damage the customer's equipment and will cost them more money in electricity. If you have any questions, call our office at 1-800-876-5375. We are happy to assist you. That's 1-800-876-5375. This has been Installing a Power Cube on HVAC, also known as an air conditioner.